actually compute a cosine, as you'll see in a minute. And then we say get pointer to function, and we print the result, calling it with the value 5. So what could possibly go wrong with this? So we have a JIT, and now we have a demo. So I will try and get this working. All right. So you can see, here's our demo source, which just jumped off onto another screen. All right. That's the function we're going to call. Not a cosine, as you can see. In fact, it squares a number. Just so you know I'm not fooling you or anything, here's the total source listing to this thing, which you basically just saw. So we're going to sit in a loop for 1,000 times, figuring out what the square of the first 1,000 integers is, which is the most exciting thing ever. All right. So we're going to run this program. And it can't find something. Oh, crud. This apparently needs to go onto my desktop for reasons no one understands. And it's totally not working. All right, so what you would be seeing, were this working, and it was totally working in my office, is you would be seeing a number print out every approximately 600 milliseconds, which isn't very exciting. So that's really slow. If someone asked you to go run your code, handed you that simple function and you took 600 milliseconds to JIT that, they would probably be very angry. So, and not only that, you use 31.5 megs of RAM to do it, which is way more RAM than like my first computer ever had. So, how can we make this better? Well, don't do anything we just told you. So, these were the things we did. Well, what can we do? We're going to optimize these areas. We're going to look at loading our library smarter. We're going to link modules in a more efficient way. And we're going to run our optimizations and transformations a little better. All right, in terms of loading libraries, what can we do? So there's a new function here that I'm showing you that says get bitcode module provider, which sounds a lot like parse bitcode file, except it hands you a module provider back instead of a module. So basically, all you're getting here is a handle. The only thing we've done is we've gone onto disk, we've looked at that bitcode file, we've read out the table of contents, but we haven't actually gone and turned any of the functions in that module into in-memory IR. So this is important because you probably don't want all 14,000 functions in libc instantiated. You're probably only going to use like 2. So, in partnership with get bitcode module provider here, there's a function called materialize function. Basically what that does is you call this on a module provider with a function pointer that you got out of it using that same get function interface where you pass it a function name. And you say, hey, materialize this for me. And it goes out to disk and it'll read the 82 bytes associated with that function. And it'll make it resident in memory. Why is this important? Well, most of the passes in LLVM don't know how to deal with things that aren't materialized, and they're not going to materialize them for you. So if you tried to inline this, it would say, oh, well, I don't see the body for that, so I'm just not going to inline it. And then you wouldn't get the performance you were looking for. So what if you don't need to inline things? So for instance, there's no reason, if you have a function that just computes a cosine of a value, to load the IR for that at compile time unless the function call overhead is so extraordinary that you really have to inline it. What you could do is compile that function to a shared library on your disk and then use the shared library API to load that and the JIT would resolve the function. So you really only need to load bitcode files for things that you really need to, specialize, change, inline at runtime. For functions you just want to call, you probably want to compile them offline into a runtime library. So now we want to, what does it look like now that we've got this thing? Well, that's what we had up above. And now here, we still need to operate on that module, to get functions out of it, to link it. So you can see the module provider here has a method called getModule that just hands us back the underlying module that's in the module provider. So what does linking look like now? Well, it turns out that direction matters. So you can see here that our runtime library, when you load it, when you call parse bitcode file on it, it loads up to 20, it dirties about 20 megs of RAM. That's a bunch, because it has 14,000 files, or 14,000 functions. So since we only want those two, if we do it the other way, we can save all that memory. And the reason that is that link modules, as I said earlier, copies all the memory. It basically copies the entire contents into the destination module. So it is one of the only passes that will materialize on its own behalf in order to get this done. So now you've taken this library that's 20 megs, and you've got your generated code that's maybe 50K sitting around in RAM, and you've copied the 20 megs from container A into container B, which is now 20 megs plus 50K. So now you've got 40 megs sitting around in memory for no particular reason. If you'd linked the other way, you would have copied the 50 kilobytes from the library, from the code that you just generated, into the non-materialized module that was maybe 300K of table of contents and other stuff, and you end up with a 350K memory footprint for having all the code you care about in one module. So that's a 100x improvement. And not only that, you're not going to be spinning the disk reading a 3 meg bitcode file, which can take a while just on its own. So if you go look at the source code for this in LLVM, you'll see references to something called ghost linkage. This is a fake linkage type like external, internal, common linkage that we've made up to represent things that are in the module but haven't been materialized yet. So if you're playing with this and you get an assert that says, I don't know how to deal with ghost linkage, or I can't print functions with ghost linkage, what it means is that you didn't materialize something that you needed to first, or the pass has not been made aware of ghost linkage. So this is one of the areas where we are soliciting community help. If there's a